Hello everyone. So today we're going to learn about how to write KVL equations for a circuit. And to start with KVL equations, so first we should know where we are going to use these KVL equations. So for applying KVL equations, we should have a mesh or a loop. So the basic difference between mesh and loop are, so we can call it as a mesh can be a loop, but a loop cannot be a mesh. So for example, like if we are having this circuit where we have, these are our different components. So in this circuit we can say that we have here two meshes. This is first mesh, this is the second mesh. But in terms of loop, if we go to count, then we have one loop, two loop, then this one is also another loop. So here we have three loops, but we have only two meshes. So this is the basic idea behind what is a mesh and what is a loop. So for KVL equations, we will be writing it with respect to mesh analysis or loop analysis. So depending on our requirement, it will vary. So to start with mesh analysis, so first thing what we require to understand is, let us consider that whatever we have learned till now, we are not going to recall anything of it. So to start with, there are two types of convention, and out of those two we will be following simply one convention. So that is why we are going to discuss only that convention, which will be whenever we are moving from higher potential to lower potential, then we call it as negative. We consider that potential as negative. And whenever we are moving from lower potential to higher potential, then we call it as positive. So this is the basic idea that we will be using for our KVL equations or mesh or loop analysis. So as we can see here, whenever a current passes through a resistor, then the higher potential is always in the first terminal, and the second terminal it is lower potential. So whenever we are writing any voltage drop across a resistor, suppose current I is flowing through this resistor R, so voltage R will be, VR will be minus of I into R. Why minus? Because it is flowing from positive to negative. So whenever we consider any current direction, along the current direction, the resistance whichever we will be coming across, the voltage drop across those resistance will always be negative. So let us consider that the voltage that we are going to get in any loop across the current direction will be negative. So let us consider this circuit. So suppose this is our voltage source Vs, and this is our current R1, and this is resistance R1 and resistance R2. And whenever we are dealing with KVL equations, then we consider only loop current. So we will be discussing with respect to loop current only, not branch current, because whenever we are going to consider branch current, then we have to write down one extra equations for all the branches. So I will be coming to that point later on. Whenever we are going to the next circuit, then we will discuss that part. So first check that we are considering this circuit. In this circuit, what we are going to do is we are going to determine the KVL equation. So for KVL equation, we will consider the loop current. So let us consider this is our loop current. So suppose the current is Is. So if we write down the equation in this loop or in this mesh, so we can name it as A, B, C, D. So writing KVL equations for loop A, B, C, D, A, or we can also write as writing KVL equations for loop 1. So it will be, so let us start from this point. So first we will be encountering Vs. So Vs is going from negative to positive, so this will be plus. This will be plus Vs. Next, we are encountering with R1. So as we have already known, then whenever we are going through any resistance in the current direction, it will be always negative. So minus of Is into R1. Next, for R2, it will be minus of Is into R2. Then coming back to D point, there is no other voltage drop, so it is equals to 0. So this is our equation for this loop. Okay, so I hope it is clear for you. So next, let us consider whenever we are having a condition with two loops. So here we are having, yes, as I have already told, a mesh is not a loop. So here we have three loops and two mesh. So for this two mesh, let us consider the current. So we consider always the current moves in clockwise direction whenever we are considering. So in this way, our whatever answers we get, that will be equal for all if you are considering the same logic. And next thing is, if your current is of whenever we are getting the result of the current, if it is coming as negative, that means whatever direction we have considered, that will be opposite. So for example, suppose I am considering this is our I1, this is suppose our current I2. So in this case, if our current value, suppose I2 is coming as minus 2 milliampere, that means whatever direction we have considered, that will be in the opposite direction. That means for I2 to be 2 milliampere, the current should be moving in anti-clockwise direction. So that is what, or that is how we determine the actual current direction. But initially, whenever we are considering, we consider that our currents are moving in clockwise direction only. Okay, so in that way our equations will remain similar for all. It is not necessary that we should always follow this convention, but as we are doing common possibilities for getting the answers, so let us consider we will be doing it considering the same logic. So using this logic, there is no issue with writing for Vs, there is no issue for writing with R1, also there is no issue for writing with R3 and R4, but the issue may arise whenever we will be writing the current for or voltage drop across R2. Okay, now as I was saying that we will discuss about loop current and your branch current. So if you consider for this circuit branch currents, then suppose this will be I1, this will be suppose I2, then accordingly we have to consider this as I3. So in this case, how many currents we have? We have three currents, but equation how many will be having? We will be having only two equations, two KVL equations, right? So for a third variable, we have to write another equation which will be a KCL equation, where current relation of I1, I2 and I3 should be required. So in case of loop currents, we will be only requiring two equations, two unknown, but in case of branch current, we will be requiring three equations, three unknown. So in order to keep it simple, so let us consider loop current only. Okay, so for this, suppose for loop 1, so the KVL equation for loop 1 will be, I am not writing the whole line, you can continue that. So here starting from this point again, so it will be Vs, next will be minus of I1 R1, next will be minus of, obviously it will be R2, but what about your current? So in this case, when we see, we have two types of current. One current is I1 moving in this direction, one current will be I2 due to your second loop will be moving in this direction. That means we will be having two currents. So as we are writing the equation for loop 1, so it will be I1 minus I2, there is no other voltage drop, so it will be equals to 0. Okay, so I hope you have understood this. So whenever we are having a resistance in between two loops, then the current will be, for the current we have to consider both the loop currents. So that means in this case, whenever we are considering for loop 1, we have current I1 in the clockwise direction and current I2 in the anti-clockwise direction or in the reverse direction. Okay, so okay, do not consider about clockwise or anti-clockwise. So just see that I1 is moving down and I2 is moving up, so definitely they are in the opposite direction. So we will be writing it as I1 minus I2. Okay, so now similarly, if you write the KVL equation for loop 2, then using our same logic, minus of R3 into I2 minus of R4 into I2, then minus of R2. This time it will be, as we are writing for loop 2, so it will be I2 minus I1 equals to 0. Okay, so this is the basic logic behind how we write equations, KVL equations for any circuit. So like this we can also go for another circuit where we might be having more number of loops. So let us consider a new circuit. Okay, so suppose this is a resistance, this is another one, this is another one, this is one supply, this is a resistor. Let us put another source here, put another resistance here, this is another resistor, this is suppose another supply, this is your. Then also let us consider one more loop like this. Okay, so for your understanding, let me increase the size. Okay, so now let us start. Let me decrease this one. Okay, so let us consider again. Let us change the color for better understanding. Okay, let us use red. So this is our Vs. Okay, I should decrease it. So Vs, suppose instead of Vs, let us use V1 because we have more number of sources. So V1, V2, V3, V4. Okay, then we have R1, R2, R3, R4, R5, R6, R7, R8, R9. Don't get afraid. So let us consider the current directions. So this is our current direction, suppose I1. This is our current direction I2. This is our current direction I3. This is our current direction I4. All the currents are in clockwise direction. Okay, so let us start writing the equations. So suppose for loop 1, okay, excuse me for the handwriting. Okay, so for loop 1 means this loop. So let us again start from this point. So it will be V1 minus of R1 obviously, but the currents will be I1 minus I3, right? R1 is having two currents, one is your I1 and next one is your I3. Both are in opposite direction, so I1 minus I3. Okay, so let me get some space here. Okay, the next will be minus of R2, and we have two currents, I1 minus I2. Then your voltage will be going from negative to positive, so this will be plus V2. Then next is R3, so for R3 it is only minus of R3 into I1. Okay, let's have some space. Okay, now we can complete our equation. So it is equal to 0. Okay, so now next is for loop 2. So for loop 2 it will be, so let us start from this point and again reach back here. So now V2 is negative because we are moving from positive to negative value, more negative potential, right? So it will be minus of V2, then again minus of R2. This time it will be I2 minus I1, right? then we have R4, so minus of R4 into I2 minus I3, right? Then this will be again negative, so V3, then minus of R8 into this will be I2 minus I4, right? Because this I4 is moving in this direction, right? So we have I4 there, then minus of R9 into I2 equals to 0. So I hope you are following. So next let us start for I3. So from this point, what we are having is R5 into I3 minus I4, right? Next we will be encountering R4, so R4 into I3 minus of I2, okay, then minus of R1 I3 minus I1. So as you can see, the beauty of considering all the currents are in positive direction is that we don't have to think even about writing the current values, so it is always negative. So for this, suppose I3 minus I4, this is your I3 minus I2, so every time it will be negative, okay, so it will be minus. So next let us write for, this is loop 2, this is loop 3, so last one loop 4. So let us write for loop 4. For loop 4 let us consider, again we are considering this point. So for that point, so it will be R6 I4 minus or plus, this will be minus B4, then minus of R7 into I4, then we are having minus of R8, and it will be I4 minus I2, then V3 is positive because we are going from negative to positive, then coming back to minus of R5, and it will be I4 minus I3 equals to 0, okay. So as you can see, this is not that tough, plus we have just followed the loop current, and if you are using loop current, the number of equations will be same as number of loops or number of mesh to be precise. So in this way you can determine the solution very easily, okay. So I hope it is understood. So we have seen today how we write KVL equations, and how we write KVL equations if we have more number of loops, and the logic is very simple, that we will be considering currents, or that is your loop current, and all the loop currents will be moving in one direction, which we consider as in clockwise direction. So that will be all. And for the solutions, you already know how to solve numericals, the more number of variables, the more number of equations. So if we have 4 loops, so 4 unknown, so 4 equations. If we have 3 loops, then 3 equations and 3 unknowns, okay. So thank you for joining. We will see you in the next class. Thank you.